Oh.
You are not the host, sir.
Something else. Let me have a look.
You are not the host.
No.
I can't hear anything. No.
Hello, is the class going on?
Yes, just wait for the lecturer.
The problem
No,
is
sir,
network.
we can't
Just
hear
wait.
anything. We can't hear anything. No.
My network.
He's muted.
Okay, sorry, I was muted. Now I've unmuted myself, so we can continue. Can you hear me now?
Yes, sir.
Yes, sir. We can hear you.
Yes, sir.
Yes, sir.
Sorry. So mute yourselves then, please. Okay. So now, under the Newton's first law of motion, it states this. That's the definition. And it's quite explicit. And what this means is that if you have an object in motion, just like I was describing this football, it was initially at rest, where your V is 0 meters per second. But the moment a force acts on it, it sets it in motion. So it moves in a straight line in the direction of the force. But if another force comes this way and acts on it, you observe that it now moves up, which shows that the direction has changed. And that is what the first law is trying to explain to us. That an object continues in a state of rest or move with uniform velocity in a straight line as long as no net force acts on it. So the moment a force acts on it, it's either it changes its position, moves with a velocity, or if it had been moving with a velocity, if a force acts on it, the velocity changes. So that is what the first law is trying to explain to us. Now, under the first law, we have been discussing about the law of inertia. And what does this inertia mean? An inertial reference frame is one in which Newton's first law is valid. And what do we mean by inertial frame of reference? That means the coordinates. For example, if you discuss about coordinates from your secondary school, when you discuss about coordinate, that means you are discussing about your X, your Y, and your Z. That is what is called the coordinate. Definitely, if you have this, and you have an object, this is your Y. Let's assume this is the X. This is the X direction, and this is the Z direction. If an object is here, you can describe its position in terms of X, Y, and Z. That means you are describing its frame of reference. If you describe it, frame of reference, if you describe that in terms of X, Y, and Z. So the same thing, an inertial frame of reference is a frame of reference that the object moves with what? Uniform motion. And that's why the first law can be defined as the law of inertia. The law of inertia, which states that an object continues in a state of rest or move with uniform motion unless a force acts on it. Unless a force acts on it. So the force itself has a lot of role to play to determine the state of motion. So the force itself could be a push or a pull. Either of the two. It could be a push or it could be a pull. That is what we observe. Is the first law cleared as I've explained?
Yes, sir.
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 Now,
Yes,
we
sir.
all know that
Yes, sir. Yes, sir.
we discuss about mass, we discuss about weight. But over time, we all misconstrue what mass is and what weight is. If you go to the hospital now and they put you on a scale, a weighing balance, majority of the people will say, what is my weight? No, you are not measuring your weight. You are measuring your mass. So the mass is a measure of the inertia of an object. That means, what is wrong with Ajayi Victor? Stop requesting for recording. You cannot record. You are not the host. What is your problem? I said it will be shared. So why are you requesting to record? So when you discuss about the mass is a measure of the quantity of material an object is made up of. The quantity of material an object is made up of. So that is its inertia, its potential. So the SI unit for mass is always the kilogram, while the SI unit for weight is always in Newton. So the mass is defined as the property of an object, while weight is the force exerted on that object by gravity. For example, if you have an object, let's still say a football. Definitely for the football to stay at rest, where the initial velocity is 0 meters per second, that means the force of gravity, G, is acting on it. But if I ask you for the mass of this ball, let's say the ball is just about 0.5 kg. But the moment I ask for the weight of the ball, that means I'll be multiplying the mass by my G. And usually the standard G is always 9.8 meters per second. But this G varies from location to location. The G varies from location to location. It's not something that is constant. But in order for uniformity, in order to solve problem and to move on, the G will be given to you. The G to assume. You assume G is 9.8. When you get to the moon, G is lesser. And that's why is in the moon, you'll find out that objects will be floating because the G is lesser. So that's the difference between the mass and the weight. Mass is in kilogram. What you measure on your balance is the mass. It's only when you multiply by the G, that is when it becomes the weight. Now, for the Newton's second law, the Newton's second law is the relationship between acceleration and the force. Here, we will observe that the acceleration here is directly proportional to the force. Is directly proportional to the force. So as the force increases, the acceleration as well also increases. But however, from the formula that we have F is equal to ma, the mass is always constant. The mass of an object does not change, except you decide to remove from the object. Maybe you use a knife to cut that object off, and you have now reduced the quantity of material. So if you multiply that with the acceleration you are giving to it, it gives you the force. So as the force changes, the acceleration changes, but the mass remains constant. But from here, you always see that the force is inversely proportional to the mass. That is the implication here. The force is inversely proportional to the mass, but directly proportional to the acceleration. Force is inversely proportional to mass, but directly proportional to the acceleration. So that is the observation. And that is what we have observed. Now, when we talk about force, because force itself, it's a vector quantity. Force is a vector quantity. And that implies that, and when you discuss about a vector, there is what we refer to as the addition of vectors. Addition of vectors. For example, if I have a chandelier in my sitting room, very heavy, I will have different strings attached to it, which is attached to the ceiling to suspend it and to hold it firm. Once this is done, this has a force of F1 acting on the chandelier. This has a force of F2 acting on it, and this has a force of what? F3 acting on the object. Now, in order for me to be able to know the total force acting on it, I must sum the forces together. I must sum the forces together. Mind you, at times, those forces might be acting at specific angle to the object. So they have to be taken care of. If they're acting at specific angle to the object, they have to be taken care of. So the SI unit of force is always the Newton. It's always the Newton. Note that pound is also a unit of force, but pound is what is used in some countries like the US. US uses pound. They don't use force. So instead of Newton, they use pound. Like we say 3 newtons, they will say 3 pounds. That's what they use in the US. So it varies from location to location. Now, if different forces act on an object, that means we can sum them up together in order for us to be able to determine what kind of acceleration the object is going to receive. What kind of acceleration the object will receive. What kind of acceleration the object will receive. So we need to sum them up. Now, the next one is the Newton's third law. We have been able to determine that the first law states that an object continues in a state of rest or move with uniform velocity or motion unless a force acts on it. That's the first law. The second Newton's law states that the force acting on an object, the second law says that the force acting on an object is directly proportional to the acceleration. So, and here when we introduce the constant of proportionality, which is the mass of the object, it gives us this. But if the forces are many, we could do what? We can sum the forces up. That's the second law. Now the third law now. Anytime a force is exerted on an object, the force is caused by another object. So Newton's third law states that whenever one object exerts a force on the second object, the second exerts an equal force in the opposite direction. Now, for example, if I am a soldier and I need to shoot a gun, I have an SMG which I need to fire. If the bullet comes out in this direction, F, this way, definitely as I'm shooting, there will always be a recoil. If I've ever watched films and you see the actors shooting with heavy guns, you find out that they themselves will be vibrating in the opposite direction. And that's the reason why at times there's a way they stand. If you are shooting a gun, heavy gun, you cannot stand straight. Your legs have to be apart this way to attain what? To attain proper stability. Because there will always be a recoil of the stuff. There will always be a recoil of the stuff. And that is the reason why it is always advisable when you alight from a vehicle, it's either you stay aside, allow the vehicle to go, or if the vehicle is still picking up passenger, it's better you go to the front, stay a bit from it, and you cross the road. Or however, don't go behind the vehicle to stay. Because for every vehicle that wants to move, for every vehicle that decides to move, if the driver accelerates, it will want to move in this direction. But ordinarily, there's always a recoil in the opposite direction. There's always a recoil. So if you are standing beside this, if care is not taken, it will recoil and just hit you. So for every action, there's always a reaction. That's a layman's definition, or for the Newton's third law. For every action, there's always a reaction. You can see this man bangs his hand on the table. The force exerted on the desk is this way, but there's always a reaction. The reaction is the impulse he feels. If he bangs it harder, he feels the pain harder. The pain becomes intense. So that's what the Newton's third law is trying to let us understand. So for every action, there's always a reaction. So any questions so far? Any questions so far?
No, sir.
No.
Okay, okay, thank you.
No, sir.
Let me proceed.
Yes, sir. There's a question.
Yes, sir.
So what's your question?
For the second law of motion, can we
Okay.
also use the rate of change of momentum is directly proportional to the force, sir? Since momentum is
Most often, you can use that, but you don't use that to define that. Always use that the force is proportional to acceleration. Because if you say the rate of change of momentum, that means the acceleration is changing. So it's no more a uniform force. Because when you talk about change of acceleration, is the same thing as this. But there's always a change of velocity. There's always that change of velocity. So the change of momentum, there's always a change of velocity. So the force is no more uniform if the velocity changes. So that's the reason why we define it as this, that the force is proportional to the acceleration. So the larger the force, the larger the acceleration. Why the smaller the force, the smaller the acceleration impacted on the object. So at a separate entity, you could define that, because the acceleration can be defined as this as well. It could be defined as that as well. So if you are talking about the rate of change, so a t comes here. So if you now brings this to this, we'll see this later on in our second PowerPoint slide. So where you have the F multiplied by the T will give you the change of momentum. So when you are talking about that change of momentum, that means this force is changing. So once the force changes with the movement of the object, then there's always a change of momentum. But if the force is a uniform force, if you're applying 10 newtons, is 10 newtons. But the moment you change to 15 newtons, definitely there will be a change of momentum. And this alone is what we refer to as the impulse. So when we get to the second slide, I'll still explain this better. We have been misconstruing this over the years in our secondary school, what impulse stands for. What impulse stands for, we have been misconstruing that. So that will be explained later on. So define that as force proportional to acceleration. So as the force changes, the acceleration changes. Even ditto to a vehicle. The more you throttle, you see that the speed of the vehicle changing. If you apply the brakes, you see that applying the brakes, you are applying a force. But the force you are applying now is a decelerating force. It's a force that is making it to stop. So there will also be a change in momentum. But once it's a uniform motion, and that's why even in vehicles, you have what we refer to as a cruise control. If you were to be in a place like the US advanced countries, where the road is so free that you don't have encumbrances on the road, once you match the throttle and the vehicle reaches maybe like 100 or 120 kilometers per hour, just set the cruise control. The vehicle continues with that speed. Uniform motion. Force is not changing until you match the brake. It will now disengage from the cruise control. So these are some of the scenarios that you can have. Any other question?
Yeah, so I have a question.
Okay. What's your question?
You mentioned force being measured in pounds in the US, but from my
Yes.
previous knowledge, weight is measured in pounds too. So does that invalidate weight being measured in pounds? And if they are
No,
both measured in pounds,
it doesn't. It doesn't at all. When you talk about force, force is what? Product of what? Mass times acceleration. Is that clear? So when you talk about weight,
Okay,
weight
sir.
is a product of what? Mass times what? Acceleration due to what? Gravity.
Gravity.
The gravity itself is also an acceleration. The only difference between your G and your A is not that your G is constant, but your A might not be constant.
Thank you, sir.
Okay. So I think we are good to go.
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Okay. So now the next slide now that you have here, just like the Newton's third law, explaining the Newton's third law. This is a rocket being launched. So when you launch a rocket, you can see releasing some gases. So there's a recoil. So the reaction are those gases that are being released. There's always a recoil. And that's why even for an airplane, if an airplane moves on the runway and is about to take off, at the point of taking off, is moving against gravity. It's applying a force in this direction, but there's always a recoil.
No one knows.
There's always a recoil. And that is the reason why when an airplane is taking off, it wastes a lot of fuel as a result of the reaction. It wastes a lot of fuel as a result of the reaction. For example, I was made to understand that for a standard airplane, you have to load in that tanker about 3 of the aviation fuel into it. But by the time it is trying to take off from the ground, a whole tanker is wasted in taking off. That's as a result of the reaction. There's an action taking off, moving up in this direction, but there's always a reaction. It is that reaction or the recoil that wastes that 1 full tanker of aviation fuel. And that is the reason, the more reason why flying is expensive. It consumes a lot of fuel while taking off. So because of the reaction, the recoil. So still on the Newton.
So the question.
What's the question?
You said to every action there is always a recoil. Can we also state the phrase, to every action there is always an equal and opposite reaction?
Yes, it must be equal and opposite, yes.
Okay, thank you very much.
It must be equal and opposite, yes. Not just a recoil. An equal one to the action. So which means, for example now, if let's assume this woman wants to kick a football. The woman is here, kicks a football with, let's say, 2 newtons. Definitely the football will create a recoil, something that is equal and opposite, which means a recoil of -2 newtons. So the recoil or the reaction must be equal and opposite. So that's the third law. So for the weight now, just like I made mention earlier, the weight is given as what? mg. It is also a force. But the force now is due to gravitational force. It's due to gravitational force or gravitational effect. So that's that. So now you have this status sitting on the table. A force of gravity acting here. So there's always a reaction from the table. The reaction is referred to as the Fn. So the force of gravity is still there acting on it, that's the Fg. So the force exerted perpendicular to the surface is called the normal to the surface. So it is exactly as large as needed to balance the force on the object. It is exactly as large as needed to balance the force so that the statue can stay at equilibrium on the table. If the required force gets too big, then something must break. It's just like you have a plastic chair, a small one that doesn't have good stability. You now ask a man or a woman of 100 kg to sit on it. What happens to it? It breaks. It will surely break. Because the reaction produced by the chair is not equal to the action produced by the human being. So definitely it will break. To break off. Once that action cannot be the same. Action and reaction must be equal. So just like this, just like I said In the next class, we'll solve problem. You will observe that you have a yacht here. Looking at this yacht on the river. It is now at the bank of the river, suspended by 2 ropes, so that even if there are water tight, it will not move away from its position. The 2 ropes hanging this are with forces of 40 newtons and what? 30 newtons. So we can be asked to calculate the total force acting on the yacht. The total force acting on the yacht. But mind you, you will observe that these forces are acting at specific angle. 40 newtons is acting at 45, while the 30 newtons is acting at what? 37 to the horizontal. Is acting at 37 to the horizontal. So in order to resolve this, that is what now brings us to discussing about summation of forces. That is what brings us to summation forces. Maybe I should describe that. Let me quickly open up a new, so that I don't move away from here. Now, if I want to, we have a situation where we have a yacht. Please hold on, let me. So I have the object now, which is my yacht. I have 2 forces acting on it. This is 40 newtons, and this is 37 newtons. Sorry. You will see 40 newtons, 30. We have at angle 45 and 37. This is 30 newtons. I have this angle 45 and angle 37. So in order for me to resolve this, remember I said in order to know the total force acting on the object, this summation of the force MA, but this is what we want to calculate. It is not accelerating now. It is keeping it at rest. The first law is either the object remains in a state of rest or moves with uniform acceleration unless a force acts on it. Now, it's at rest, but we want to know the total force acting on this object. In order for us to be able to do this, the simplest way to do this is this. For those of you that actually offered further mathematics in your secondary school, this is not strange to you. If you have a force, for example, I have my Cartesian coordinate. This is my y, this is my x. If I have a force of 5 newtons acting at 30 degrees to the horizontal, I can resolve this force 5 newtons into both the vertical axis and the horizontal axis, whereby I will now have Fy and I will have the force resolution to the x-axis. So in order for me to calculate the Fy to determine that's this 5 Newton force, what is its resolution to the vertical axis? Because it is acting at an angle 30 to the horizontal. In order to calculate that, that will be my 5 sine what? Sine 30 degrees. 5 sine 30 degrees. But if I resolve these to the horizontal, that will be the 5 newtons cos 30 degrees. Cos 30 degrees. So I've been able to resolve this force acting at an angle to the horizontal, both to the vertical axis as well as the horizontal axis. So for each of these now, we will need to resolve it both to the vertical as well as what? As well as to the horizontal axis. Each of them, then we then sum them up together. So in order to do this, to make this very, very simple, we'll do this. You can have a chart, a table. If you have this table now, you have your force F. Then you will have their resolution to the what? X. You also have resolution to the what? To the Y axis. Now, if you pick the 40 newtons, now you can extend this. You can see the way I've extended it. So that I now have a proper Cartesian coordinate. Here, what I have here is my negative what? Y. My negative X. Here, what I have here is my positive X. And what I have here is my what? Positive Y. And here I have my negative Y. Now, if I pick up the 40 newtons, I will observe that the 40 newtons I have is perfectly to the positive Y and what? Positive what? X axis. So that makes it very easy. So when I now come to resolving this for the 40 newtons to the horizontal, that will now become, if I resolve to the horizontal, it will have what? Cos. But with the 40 newtons have plus or minus to the horizontal, it will have plus because it is in the positive X direction. Quadrant. We have 4 quadrants now. This is the first quadrant, second quadrant, this is the third quadrant, and this is the fourth quadrant. So when you look at it in the first quadrant, it is to the positive X, positive Y. So I will then have what do I have here? That will be 40 cos what? 40 cos
30.
45.
So I have a question.
Yes, what's your question?
Would we be getting the recording after the class?
Yes, the recording is recorded. Don't worry.
Okay, sir. Thank you, sir. Because I have to go and pray now.
Now,
Sorry, sir.
yes,
Sir, will the notes be sent after the class? The notes of this teaching, or just
don't worry. The issue of notes will be resolved later.
okay, sir?
I'll get you informed.
Okay.
Maybe by Thursday. So this
Oh, I
recording
bet.
will be sent to you.
Bet.
Now, with this one now, if you are now resolving to the Y axis, now, because it is to the positive, now be plus 40, now be 40 sine what? 45 degrees. That is what you will have. Now, if you move on to the 30 newtons now, for the 30 newtons, if you look at this, if you look at the 30 newtons, it is to the what? If you look at the quadrant, it is to the positive X, but negative what? Negative Y. So to the X now, you have
37 is not 30.
30. Now be 30 cos what?
Sorry, bad. Okay, bye, Joe.
37. But now, because it was the positive Y, you then have what? Minus what? Minus
30
30 sine 37 degrees. So thereafter, you can then find each of them and you sum up.
Sir, I have a question.
This up, that will be summation f of x, and you also have summation f of y. So you find cos 45 multiply by 40, you will add it to, you find cos 37, multiply by this, and you sum the two together to have your solution here. So you also come here again, sin 45, you find that, multiply by 40, find sin 37, multiply by minus 30. You so which means you are subtracting this from this. So you also write whatever it is here. You also write whatever it is here. So in order for you to now find your F.
Sorry, sir, I have a question.
What's your question? What's your question?
Sorry, sir. Is it possible that we put the minus sign in the angles?
No, you cannot put the minus sign.
Add the minus sign in the
No.
angles.
Because the angle is not a vector quantity. Is that clear? It is the force that is a vector quantity.
Okay. Yes,
I'm putting the minus in the force, in the 30, it has shown you the direction it is to the vertical. Is it clear?
No, sir.
Because you are always resolving to the horizontal.
Yes, sir.
So now, in order for you to now get your total force, F, it will now be the resultant of this, which we call the resultant force of the object. It will now be your summation of F of x squared plus summation of what? F of y squared. When you sum these two together, whatever you have there, you find the square of this, sum them up together. When you sum them up together, you now find the square root. That gives us the total force that is acting on this. Yes.
Sir, that total force, it's acting like the resultant or something.
Yes, it's the resultant. That's what I said. That's the resultant force on the object. But because it is acting at different angles, that is why we are using this method. It's always quite easier using this method.
Okay, sir.
It's very, very simple.
So, okay, so is this force that is keeping it at rest?
Eh?
Is it this force that is keeping it at rest?
Yes. Is this force now, is this resultant force here that is keeping that object at rest? Is that resultant force?
Okay, sir. Thank you, sir.
Or if it is in motion, if those two forces are pushing it, one is at the other side. For example, now, if you have a cattle or a cow that wants to be slaughtered, you are moving it from where it was tied down. You observe that some people will be pulling by the leg, some will be tied to the neck, another person will be pulling by the leg again in order to pull it down, to fall it down. Do you understand that? Even moving it.
Yes, sir.
So the one that want to know the total force that is moving, or the total force that is keeping it at rest.
Side question.
So it's the resultant. So and that's the way we call this resolution of forces or addition of force, addition of vectors. So I hope it's understandable.
Yes, sir. Very well. Thank you so much.
So now, so these are some of the problems, and you could have it in such a way that you have.
Sorry, sir. I have a question.
An object sliding on an inclined plane. An object sliding down an inclined plane has three forces, and the three forces are the one due to friction, because there's a friction on the plane. The motion is down this way, but there's a frictional force acting equal and opposite up. But because it is resting on the plane again, it's exerting a force on the plane due to gravity. And there's also an equal one due to the gravity again, which we refer to as the normal reaction. So from your O levels, you will observe that if you are calculating the normal reaction, it has its formula. If you are calculating the one acting downward or due to friction and all other stuff, even if you pick up your PNOKK, it's there. So those textbooks are still useful. But by Thursday, I'll give you a feedback on the notes and whatever. I'll be able to give you a feedback by Thursday. So basically today we have been able to study the the laws of motion, which were laws proposed by Isaac Newton, and they have all been verified and they have been passed into a law. We have the first law, we have the second law, we have the third law. The first law states that an object will continue in its state of rest or uniform motion unless a force acts on it. Unless a force acts on it.
Is that not inertia?
Which is also the law of inertia. Yeah. It's also referred to as the law of inertia. Just like I said, the law of inertia makes us to understand what we refer to as the inertial frame of reference. So this is a frame of reference that has uniform velocity.
Can you explain that again, the inertial frame of reference?
So inertial frame of reference, for example now, where you are listening to this lecture now, you are not moving. Is that clear? You are not moving. So now that frame of reference in which you are, you know, it's with specific to a coordinate on the surface of the earth, but you are not in motion. Or even if you are in motion, if you are in a car using your phone or your tab now, you are in uniform motion in the car. The car is not accelerating. It's also an inertial frame of reference. An inertial frame of reference is the coordinate or a frame of reference in which an object is, but it is with a uniform motion. That's what is called inertial frame of reference. It's a frame of reference or a coordinate that is with a uniform motion. That's it. So the second law states that our force is proportional to acceleration. So the larger the force, the larger the acceleration. So where we introduce constant, which is ma. But at times, if it's under gravity, we can introduce mg. So that is the second law.
Does this also apply to weight?
The third law says that for every action, there must be equal and opposite what? An opposite reaction. So if you have -2 newtons acting on an plus 2 newtons acting on an object this way, there must be a recoil or a reaction of -2 newtons in the opposite direction. So these are the 3 laws of Isaac Newton that actually makes us to move on with science and has really been able to explain the motion of objects on the surface of the earth. So thereafter, we're able to see that we could actually calculate resultant force. And in calculating resultant force, we were able to use this method, which is a very good method to calculate resultant effect of forces on objects. So any question?
Yes.
Sorry.
No,
Can we see the second slide?
The what?
22nd slide.
I should.
Can we see the 22nd slide?
Okay, the 22nd slide. Okay. No problem. This is it. So he's talking about frictional force. He's talking about the frictional force on that object. This is one. Static friction is the frictional force between 2 surfaces that are not moving along each other. For example, you have a surface this way. You have an object that is at rest. Here, u is equal to 0. But the surface is rough. The surface is rough. So if the object is at rest, so the object is not moving with respect. So what you have is static friction. So when the objects are not moving relative to each other, you have static friction. But when the point it starts to move, that is when we have what is referred to as the dynamic what? As the dynamic friction. So that's the difference between the static friction and the dynamic friction. So static friction keeps the object on incline from sliding and keeps object from moving when a force is applied. So if you are trying to apply a force here, it tends not to move. That's the static friction it's having. So later on, it will move. At the point it starts to move or slide, then you have what is referred to as the dynamic friction. So this is what you have here. You can see the applied force, the static friction, or is either dynamic or kinetic friction. So or this can be referred to as the
Sorry, sir.
dynamic
Okay, sir.
as the dynamic
So I
friction.
want to ask a question.
So what's your question? What's the
So
question?
what about if an object is placed on another object and they're moving? What if a object is placed on another one and they are both moving at the same time? Is any friction applied?
Yes, friction can be applied, but in that situation, you'll be discussing about the kinetic or dynamic friction because it's in motion.
And
Is
the
it-
second, sir, I have
Question.
a question.
Okay.
So what's your question?
So I said in the second law that F is equals to A. Does it also apply to G? Gravity.
Yes, your W, which is the same thing as F. It also applies to that. Because the G is also an acceleration. But it's just an acceleration that is due to gravity.
But
My question.
the G is constant.
But the G is constant, yeah.
I have a question, sir.
So what's your question?
Yes.
Yes.
So that means the F will be constant.
What did you say?
If the G is constant, then it's not supposed to be equal to the W or F.
If the G is constant, if the G is constant,
will the F be constant too?
Yes.
Yes, the F will be constant now.
Wow.
Except you are in motion. Because there's what we call, well, I can explain this in a layman's. If you have a well, is that clear? If you have a water fetcher or a bucket, when the bucket is outside, it has its own weight. But the moment it gets into the water, what happens to it inside the water? It becomes lighter. As a result of what?
Upthrust.
Upthrust. But the moment it comes out, it becomes what? It becomes heavier. Ditto to when you have an elevator. If somebody is an elevator, if the elevator is coming down, you know it's always plus G.
Yes.
If the elevator is going up, you have minus G. So there's a stage is reached where the weight is zero. That's when we talk about weightlessness. Maybe in the next class, I will try to
explain like space.
On Thursday. I will try to explain that on Thursday. When you have a man in an elevator, when you have a man in an elevator, when it's going up, it's going up, what it experiences is quite different from when it's coming down. When the elevator goes up, it's quite different from the weight when it's coming down. So that will be explained in the next class. I'll try to do that on Thursday.
Okay.
About an elevator. What is observed inside an elevator. That's the only time you have your W changing.
My question. Sir, please, I have a
Okay. What's your question? What's your question?
How come you get minus?
How can you get minus what?
The FY axis, sir.
The FY axis, you mean the problem I solved earlier? We are having minus 30 because if you look at the quadrants now, can you see the 30 Newton force is to the negative what? Negative Y axis or to the positive what? Or because it is the negative Y axis, that is why we have minus 30 here for the Y. resolution to the y. But if you look at this, the 40 here is to the positive y and positive x. That's why you have positive here. I hope it is clear. That's why you have positive x, positive y. But for this, positive x and negative y. So
I have a question.
About this, I want to ask a question.
Okay. What's your question?
Sir, between weight and mass is measured with which instruments, sir?
Mass can be measured with various instruments. For example, if you're a chemist, or for those of you in the medical science, a pharmacist or whatever, there's always a balance in the lab. A scale, we call them the scale, which are very, very small.
Being
But
balanced.
they're always sensitive to air. So you can use that to measure the mass of the chemical you want to mix up with the other one. Or for human being, we have the scale that we use in the house or to weigh. We also have what is called the spring balance. For all these metal scrap pickers, when they pick all these metals, by the time they take it to Owodi Oniri or whatever, where they will sell it, they use the spring balance. The spring balance is always this way. What I showed you at the beginning of the class, this. So the spring balance is always this way. So it could be something. The spring balance is on this way. You have a spring inside this, and this is calibrated. So the bag of the scrap metals is here. So by the time you hang it, it tells you the actual mass of the. So there are different things that can be used to measure the mass. There are various things. Also in the lab, in the year 1 lab, we have what is called the beam balance. The beam balance is this way. You have an apparatus this way that has lever. You have your lever that you use to balance it. It has a plate here, another plate here. A known mass is placed here, while the unknown is placed here. So as you adjust this, you continue to adjust so that you can take the necessary reading. So a stage is reached where it balances up. So it doesn't, it's not just like a seesaw. So its balance is at equilibrium. Then you can take your measurement on the scale here. So there are various things, measuring instruments that you can use to measure the mass. But if you now want to measure the weight, whatever mass you get, multiply by the G of that location. Multiply by the G of such a location. You multiply by the G of such a location. So I hope.
Is this the first official class for physics?
No, there was a class last week on Monday and Thursday.
Okay, thank you.
There was a class last week, but this is the second week we are having lectures for year 1 in physics.
Okay, sir.
I also ask a question.
Please, the question, because some of you still have another class.
Can we have this slide, sir?
Are we supposed to partake in it too?
You're supposed to partake in where?
I said the class was for medical students. Are we supposed to partake in it to the science students?
Yes, you are. The science students too, you are supposed to.
But like the
Even
classes are
engineering
clashing now.
students, even
There's one
environmental
medical
students,
class.
even environmental is for the entire university. Usually
But, sir,
physics are for the entire university in year 1.
Sir,
Yes.
there are 2 physics classes happening like at the same time, yours and another woman's class.
Okay.
So how are we supposed to join the 2 of them?
You can join whichever one. We are teaching the same thing.
Oh, okay.
We are teaching the same thing. But by Thursday, it's going to be harmonized. I think that's what we'll do. She has sent me a message, so I'm going to coordinate. Because I'm the coordinator.
All right, sir.
I'm the coordinator. So we coordinate. If we can now, ordinarily, if it be physical classes, 3 of us are supposed to be teaching at the same time, teaching the same thing together. 3 of us are supposed to be doing that at the same time. To do physical class. So
I
we
have a
could set
question.
up many different Zoom links, and you can join whichever one you want to do. We are teaching the same thing.
So will you be the one taking our lab also?
Eh?
Oh,
No, when it is time for lab, the subdean will inform you on the platform. The subdean will inform you. I hope it is
Alright.
clear.
Yes, sir.
The subdean will inform you. So now I want to end the class now. You will have the recording from the subdean. I hope that is clear.
Sorry, sir.
I hope it is clear.
Sir.
Sorry, sir, please. Can we get the
Yes, sir.
slide?
No, it's okay. It's okay. Whatever
Slide.
question you have, put it on your platform. The subdean will forward it to me, and I will respond, please. Because the subdean has been calling me.
What's up,
Another class is supposed to commence now from his end, and we are using his Zoom link. Okay. So see you.